Okay, YouTube, in this video we're going to be focusing on what we call a reference angle. And so when we talk about any angle in standard position, you can see that there are three illustrated here, one that terminates in the second quadrant, one that terminates in the third quadrant, one that terminates in the fourth quadrant. And I suppose that we'll go ahead and supplement this list here. What if we have an angle that terminates in the first quadrant? So this would be something like maybe this angle here. But given any angle in standard position, we say that it has an associated related angle or a reference angle. So let's go ahead and read the definition of a reference angle. We say that the reference angle of the angle theta, so the reference angle for the angle theta, is the acute angle theta prime formed by the terminal side of theta in the x-axis. And so in every one of these instances here, what we want to say about reference angles, I suppose are two things. We say that they are positive and they are acute, okay? But their definition is essentially, given some angle theta, this is the angle that's formed between the terminal side of the original angle and the x-axis. So when you look at this angle theta in this quadrant 2 termination example, what you're seeing is that the terminal side is this side right here. And we say that the reference angle is this outer angle formed between the terminal side in the x-axis right here. And you'll notice that they use this and we refer to this as theta prime. So theta prime is the reference angle for the original angle theta. So looking at these other two illustrations here, using the same definition, we would say what's the reference angle on this third quadrant terminating angle here? And we would say, well, if here's the terminal side and here's the x-axis, then here is the positive acute angle that's formed between them, theta prime. And then last but not least, for this big angle theta here that terminates in the fourth quadrant, we say that its reference angles between the terminal side and the positive x-axis here in this case. But we'd say here's our positive acute theta prime that lies between the terminal side and the x-axis. So that being said, the reference angle here, a large part of what we do is try to find reference angles given a original angle theta. So, for instance, let's say hypothetically I were to say that this is a 30-degree rotation right here. Of course, we would know that this would mean that this is a 150-degree rotation right here. But given an angle that's 150 degrees, hypothetically, we would say then what is its reference angle over here? What you're going to see is that down below each of these three examples here, it says in degrees or radians, here is how we're going to find the reference angle. So that is to say, if you're a 150-degree angle, then you terminate in the second quadrant. But if you terminate in the second quadrant, if I wanted to find this 30 degrees in the first place, let's say I don't know what this is, then what we're going to need to do is we're going to say, let's take this entire 180-degree measurement that rotates all the way over to here. And what we'll do is we'll subtract off the 150 that you see terminating in the second quadrant. And by doing this, by saying 180 total degrees minus the 150 you've already rotated, what you get left with is that leftover reference angle right here. So for angles that terminate in the second quadrant, what we'll do is we'll take 180 degrees and subtract off the angle we're given, and that should leave us behind with the reference angle. Now for something like this over here, let's say that our original theta is like a 210-degree angle. Then I would say that, well, then the reference angle is this leftover right here, but you could see that if we were to take 180 minus 210, that's not going to leave us behind with this inner angle right here. So what our tact is in this case is to actually take the angle we're given and subtract off 180. That is to say that if this red angle, this one right here, is 210 degrees, and this angle right here is 180 degrees, if we were to take the entire 210 and subtract off the 180, we'd be left over with this portion right here. So again, for something like this, we would say if you terminate in the third quadrant, then theta prime would be the angle we were given, theta, which is in this case 210, minus that 180 degrees, we get left behind with this 30-degree reference angle right here in that hypothetical situation. So for the last example here, what it says is if you terminate in the fourth quadrant, take the angle that you're given, and what you're going to do with it is you're going to take a full rotation, or 360 or 2 pi, and you're going to subtract off the red rotation that you're given, and that should leave behind this reference angle right here. So these methods certainly work. And I guess one thing I want to say over here for the first quadrant terminating thing is that if you are a first quadrant terminating angle and you're acute, then you are your own reference angle right there essentially. But what we essentially want to do is be able to find reference angles given some initial angle either in degrees or radians. So my suggestion is to go ahead and start by sketching an image. We're going to say that our theta in this case is a negative angle, so we are going to rotate clockwise. And we're going to rotate 220 degrees. So we know this is negative 90, this is negative 180, and I know that this is negative 270 if we're rotating clockwise. So with respect to a negative 220, what I know is it's at least 180 to right there. Now, if I were to say how many degrees past 180 would I have to rotate to get to 220? I know that I would have to rotate past 40 degrees. So we would say that my negative 220 degree angle, I'm going to label this right here, negative 220 degrees, we say, well then what's the reference angle? Remember, the reference angle is between the terminal side of this angle and the x-axis. And so our reference angle is this theta prime right here. And in order to figure this out, what we'll do is we'll just take our initial 220 and we'll subtract off the 180 that we just rotated here. We'll leave behind this leftover portion. So it's reasonable to say that that would have to be 40 degrees right there. So now, with respect to this was theta. What we're going to write as theta prime then is 40 degrees. And just to be clear on this, remember that we said that reference angles always have to be positive. So positive 40 degrees. So now looking at this next measurement here, this is clearly in radians and we have 15 pi 16ths. So with respect to sketching this, suppose this one's a little bit more difficult to form a sketch for. I know that we know that this is a pi rotation and that this is a 2 pi rotation. So with respect to where 15 pi 16ths would lie, if I were to change these instead of being pi wholes and 2 pi wholes to 16ths, we would say that this would be 16 pi 16ths right here, and that to go all the way around you would have to go 32 pi 16ths, which would be the same thing as 2 pi. I think the idea is that if this is 16 pi 16ths right here, then 15 pi 16ths would just be 1 pi 16th short of 16 pi 16ths. So if this is our 15 pi 16ths, and that all the way over here is 16 pi 16ths, then we can see that by taking that 16 pi 16ths and subtracting off the initial 15 pi 16ths, we should get this leftover reference angle right here that we're calling theta prime. And in this case, the theta prime happens just to be a 16th of pi rotation. So we would say that our theta prime, if this is our theta in this case, our theta prime is then pi 16ths. But those reference angles are what we have here formed between the terminal side and the x-axis. They're always positive, always acute, and this would be a nice little guide to help you determine them if you're having difficulty doing it visually. Cheers.